Hey there, welcome back to the channel. Today we are showing the database MCP server, a tool that connects databases to Cloud Desktop using the Model Context Protocol. We have built this system and this video focuses on showing what this server can do. If you want to know how one AI model can seamlessly manage the databases, this video is for you. So first, let us understand what is MCP or Model Context Protocol. Model Context Protocol is a standardized way for AI assistants like Claude to interact with external tools and services. Think of it as a universal translator that allows Claude to understand and use our databases as if they were part of its built-in capabilities. Instead of just talking about databases, Claude can actually query them, insert data, and help us manage our database operations in real time through natural language conversations. Now let's understand this database MCP server. This database MCP server transforms Claude from a simple chatbot into a powerful database administrator and analyst. By implementing the Model Context Protocol, we have created a bridge that allows Claude to query multiple databases simultaneously, databases like SQLite or PostgreSQL. It can perform CRUD operations, and it can manage database connections. This database MCP server is built using Python programming language. The system supports two database types, SQLite and PostgreSQL. We use the fast MCP class, which is part of the MCP library for server development and provides the necessary tools for implementing the Model Context Protocol. The required software includes Cloud Desktop with MCP support for the chat interface and pgadmin for the PostgreSQL database connection. This application is designed for a wide range of users. Data analysts and scientists can query and explore datasets using natural language. Software developers benefit from rapid database prototyping and testing. Business intelligence professionals gain quick data insights without SQL complexity. Database administrators enjoy streamlined database management tasks. Product managers get direct access to product data and students and educators can learn database concepts through conversational interaction. Now, let's open the Claude desktop where we have installed our database MCP server. Once it is opened, we can see that there is a button called Search and Tools. And after clicking on which, we can see all the tools. For example, here is our database MCP server, and then its associated tools are mentioned here. And we can also see that there are other servers as well. For example, this, and this is currently disabled. If we click on this, then it will be enabled. And here is another database MCP server named e-commerce catalog. So after configuring this into the Cloud desktop, we can see all our MCP server that are available in this search and tools button. Also, if we go to file, settings, and then developer mode, we can see our database MCP server, which is currently running. And we have configured the environment where we have provided the Python executable file. And then we have mentioned the Python file in which the code for database MCP is mentioned. And then we have also provided the environment variables in which we have provided all the libraries that are required to run this MCP server. And then here all the other MCP servers are listed. What we are seeing currently is database MCP and it is running. Now it's time to check the working of our database MCP server. And to do that, we will give our first prompt saying show the connection status. And this will show whether we are connected to any of the databases or not. And it says currently there are no active database connections. And it also says that there is a sample database available at this path. So let's connect with the database and we will give it the prompt connect with the sample database. And now it says that it is connected to the sample database. And it also provides us the information related to the tables. For example, it says that there are four tables: users, product, orders, and SQLite sequence. Among these, the first three tables, that are users, products, and orders, are created by us. And the SQLite sequence is created by the SQLite library of Python. As we have created this database with the help of Python's SQLite 3 library. And to connect with the database and to extract the information, it uses this tool called Get Database Tables. If we click on this, then this tool has this path called database path, and it is set to the path of the database that we have provided. And then there is another tool called list database connections, which tells us whether we are connected to any database or not. And with the connection status, you can see it is connected, and database type is SQLite sample database. The path is this, and it has these tables: users, products, orders, and the SQLite sequence. Now we will check the users data. To do that, we will type show the user data, and now it is using the query database tool to get the users data. And it says that there are 12 records in total, and this table contains 5 columns: the ID, which is the ID of the users table, name of the user, email ID of the user, the age of the user, and the date in which this particular record is created. Here we can see it says the table contains user information with fields for ID, name, email, agent creation, timestamp. And there are some other information like ages range from 25 to 42. Now let's check the products table. So we will type show the products data, and here we can see the data for our products table, in which the first column is the ID of the products table. Then we have name of the product, the description of the product, the price associated with this product, the category of the product. For example, this is a laptop, and then we have this category electronics, then stock, which means that how many products are in the stock. And here it says that 50 products are in the stock. And then we have created date, which means the time in which this particular record for laptop is created. And we have some information related to the product categories. For example, how many products are electronics product, and then we have products related to the kitchen. So the first one says that there are four products related to the electronics, which are laptop, headphones, smartphone, and monitor. It also provides us with some additional information related to the table. Now let's see the orders table. So we will give it the prompt show the orders table. And here it says that there are 26 records in this table. And as we can see, we have the ID column, which is the ID for the orders table. Then we have user ID, which refers to the user ID in the users table. Then we have product ID, which is the product ID in the products table. Then we have quantity column that refers to the quantities of the product that have been ordered. Then we have total amount, which refers to the total amount of products that have been ordered. Then we have status, which refers to the delivery status, whether it is completed or it is pending. Then we have order date, which refers to the time at which a particular order is made. Now let's see all the orders with their usernames and product names, as they are not in the orders table that we have currently seen. So let's do that. I will write show me all the order with user names and product name. And here it is performing the query. And we have got our result. And here we can see we have got our customer name and product name. And if we open this query database, then we can also see the query that has been performed. So we can see we have selected order ID, username, product name, quantities of the product, total amount of the product, status, and order ID. And we have used here orders table, users table to get the username, and products table to get the product name, and order by, which is by order date. And we have ordered these in descending form. So here we can see first we have the maximum value, which is 7th of July 2025. And at last we have the minimum value, which is 18th of January 2025. So it is in descending order. So we have successfully performed this operation. Now we will run a query in the users table to get all the users that are above 30 years. So let's do that. We will write find all users who are older than 30 years. And it has performed the query and we have got our result. So as we can see, we have got all the users who are older than 30 years. And there are 6 users total. And we can confirm if this is true by just counting from the users table. So here is our user table. And as we have mentioned that it is above 30 years and not 30 years and older than that. So it will only consider the age which are older than 30 and not 30. So here we can count. Here is the first one, then second one, we have third one here, then we have fourth one here, then we have fifth one, and then we have sixth one. So we can confirm by this that our result is correct. We have 6 users who are older than 30 years. So here we can see we have got all the users with age between 25 and 35, and there are total 10 users. Now we will ask it to provide the total number of users, average age of the users, and the count of the orders by status. I will give it the prompt get total number of users and then average age of users and count of orders by status. And here we have got our result. It has called the query database tool two times to get the result. In the first one, it says there are 12 users and then the average age is 31.3 years. And it has also provided us with the age range, which is 25 to 42 years. So the users table contain the age between 25 to 42 years. Now we have order status breakdown in which there are 8 instances having completed as a status, 7 instances having processing as a status, then there are 6 instances with cancelled as a status, and then there are 5 instances with pending as their status. It has also provided us with the percentage value for each status. Now we will ask it to find all completed orders for electronics products with total amount greater than $100. So let's do that. We will write find all completed orders for electronics product with total amount greater than $100. And as we can see, there is only one record for electronics product in which the status is completed and in which the total amount is higher than the $100. Now we will ask it to get the first 3 users from the users table. So let's do that. Get the first 3 users from the users table. And here we can see the result. We have got the first 3 users from the users table. And now we will ask it to get the users from 4 to 6 index. So let's do that. So we have got our result. And as we can see, the ID starts from the 4 and it ends with the 6. So we have got our records from 4 to 6. And now we will perform the pagination to show the product with a limit of 2 records per page. So let's do that. We will write. So we will write show products with a limit of 2 records to test pagination. So it is now performing the query and it will show the 2 records. So in the first prompt, it is showing the first 2 records. Here we can see there are laptop and coffee mug. These are the first 2 records. And it is asking if we would like to see the next 2 products. So here we can see it is showing the next 2 products and it is also monitoring the records that are being shown. So here it says that we have shown the 4 out of 11 total products. There are 7 more products remaining, and it says that if we would like to continue, so we will write continue. And here we can see the next 2 products are available, and we will ask it to continue with the 4 records instead of 2 records. 4 records instead of 2 records. And here it is showing the 4 products. And now it is saying that only 1 product is remaining. So let's check that as well. So this was the final product. And these are some of the basic operations that we have performed on this database. And if we want to connect another database, let's say we have this university database that contains the tables related to university. So we will simply copy the path and ask it to connect with this database, and it will search for the path and check if this database is present or not. And if it is present, then it will be connected. So here you can see it has connected with the university database, and it shows the available tables such as students, professors, courses, enrollments, and the table that is created by the SQLite, which is SQLite sequence. So it is performing the query for each table, and it has performed the query. So these are the first 5 results of the students table. We have got the ID, the student ID, the name, email, and all the related information. Then we have got the professors table, which contains the information related to the professor. Then we have courses table, which has all the information related to courses. Then we have enrollments table, which contains the information related to student ID, the course they are enrolled in, and their grades, status, and the date of enrollment. Now let's check the connection status. So it says there are 2 active connections. The first one is sample database, and the second one is university database. And we have got the information like the path of the database here, and the type, which is SQLite, then its status, which is whether it is connected or not. So it says that it is connected and initialized. And then we have this sample database. As this sample database is already provided in the code, so we are checking if this database is sample or not. So it says that yes, it is a sample database. And then it shows the tables that this database has. And for the university column, the sample database value is no. And then we have the corresponding table names for this database. And in summary, it says there are total 2 active connections and both databases are connected and ready for queries. And it says that we can switch between databases by specifying the database path in queries. And it also tells us that both connections are SQLite database and are fully initialized. Let's say we want to connect with the database in a PostgreSQL server. So let's do that. First, we will go to the pgadmin to see which data we would like to connect. And here we can see we have university database, which is the same as the previous database that we have included. So, so we will write connect with the PostgreSQL database. So it says that it requires host name, database name, the username and password, and also the port name. So let's provide it the credentials. So let's say to the host is localhost. The database name is university database. Username is Postgres. Password is Ganesha and the port is 5432. So this is my credential. You have to provide your credential to connect with the database. Also, I am providing this credential of the PostgreSQL server that is running on the local system and not in any production environment. And we are doing this because of this security reason. Let's now hit enter. So it says that the connection failed because the university database does not exist. And I think I have provided it with the space instead of underscore. And it says that it will try a few common variations. And if we see this, then we can see that it has tried the university underscore database here. And as we can see the credential here. So if a query fails in the first try, then sometimes the Claude tries to try the variant of that query to get the correct result. And it works in this case. Here we can see the PostgreSQL connection is stabilized. And if we ask it again to provide the connection status, and in the last one, we can see university database PostgreSQL. The type is PostgreSQL, and it has provided us with the local host name, the username, the status, which is connected and initialized. It is not a sample database, and the tables, which is same as this because this is the same database. Now, let's check the first 5 values of this university database in the PostgreSQL server. So we will write provide the first 5 rows of the tables in university database in PostgreSQL. So it is now performing the query. And here we have got the tables from the PostgreSQL server. And we can check if this is actually from the PostgreSQL through this request. And here we can see it has written PostgreSQL. Now let's disconnect with one of these data. So we will write disconnect with the SQLite University database. And with the help of close database connection tool, it will disconnect with the university database. And here we can see there are only two connections available. One is for sample database and another one for this university database. Now let's connect with this again. So now we have three active database connections again. So we have the three databases currently that are connected. We will perform some operations on the sample database because there are operations that are remaining. So let's perform those operations. So now we will give it a prompt to add a new product in the product table. So let's do that. Write add a new product, and then we will provide the specification. Its name should be wireless mouse. Its description should be wireless mouse for gamers, and then its price is $39.99. Its category is electronics, and in stock there are 150 quantities of this gaming wireless mouse. So let's hit enter. So we have successfully added this new product, and as we can see, it has given us the product edit information with index ID 12, which is auto-generated ID, the name of the product, which is wireless mouse. The description is provided as well. The price is 39.99. The category is electronics, and it has given us the message successfully added the new product, and it has now provided us with the database information, which is sample database SQLite. It has provided us with the table information, which is product table, and it has also provided us with the number of rows that is affected. And as we have performed a single insertion query, so it says one. So one row has been affected. If we have added the two rows, then it would have said the two. And if we delete or update the two rows, then the value of affected rows will be 2. Now let's check the products table to check if we have successfully added the data or not. So provide the product table. So here we have our products table, and now it has 12 products. And here we can see we have our wireless mouse product here. The description: wireless mouse for gamers. We have price, electronics as category, 150 as the quantity of these products, and the time in which this product was added. So we have successfully added the new product to the table. Also, if we don't provide the date and time, then what it will do is that it will use the current date and time as the default value. And in here, if we don't provide the database name, so what Claude does is that because of the previous query, it already knows that the product is available only in this particular database, and it will perform this operation in that database. Now let's a new record in the orders table. So let's do that. We will write create the new order in which user ID is 1, product ID is 2, quantity is quantity is 3, and the total amount is defined as 38.97, and the status is set to pending. So the Claude is smart enough to know that it is for the user ID 1, which is Alex Chen, and the product is coffee mug, and it says that it has successfully created the new order with all this information, and the order date is auto generated, which is current timestamp. And as we have inserted the row, it provides the database name, table orders, and affected rows as one. Now let's check if this new record is indeed added in the orders table. So we will give it the prompt. Through the order data. And it says that it will show us the complete orders table, including the newly created order. So as we can see here, our new order is in the first row, and as this table is ordered by the descending order by date, so here is our order date, and the newly created column will appear first. Now let's insert a new user, and to do that, we will type insert a new user with the name, let's say user1 for simplicity, and then we will also provide the email user1 at the rate user1 at example.com. Then we will hit enter. So it says that it will add a new user with the name and the email that has been provided. So as we can see, it has added a new user in the 13th row, which is the auto-generated ID, and the created a date in which this record is created, which is set to current timestamp, and the age is not specified, so it will be null. So let's see if this value is indeed added in the user's data. So we will type show users data. So here we can see our newly added row, which has the name user1 and the email ID user1 at example.com. The age is null, and the created at date, which specifies the date in which this record is created. Now we will simply insert a user with only email. So let's do that. We will write insert a user with the email address user2 at example.com. So it tries to add a new user with the email address user2 at example.com, and this does not have any name or any other attribute. It only has the email attribute, and while performing the insertion, it says that the insertion failed because the name field is required. And then what it did was that it added a new username called user2 by itself, and the age value is set to none. So it added a new user to the table. Now let's add a new record in which only the age is provided. So let's do that. We will write, let's say 27. So what it does is that it is following a pattern from the previous conversation and adding a new user with the username user3. And it is doing this because in this schema, it is provided that the name and the email address should not be null. And as we have discussed earlier, the Claude sometimes tries to resolve the issue by itself. And that is what it has done here by adding the name and the email address by itself. Now we will delete some information from the users table, and to do that, we will type delete the user with email address as user3 at example.com. So it is saying that it will delete the user with email address that is provided, and it will first preview what would be deleted for safety. So first it preview the deletion operation to check what is to be deleted, and then it says that this is correct user we just added, and it says that The deletion was prevented because this is a sample database and the system has safety protections in place to prevent accidental data loss from sample databases. So because of the safety protection that is added in the MCP server for the sample database, it is not allowing us to perform the deletion operation. And this is for sample database, and we can do this for any other databases as well. This is to make sure that we accidentally do not delete any important data. And if we go here, we can see a message saying deletion from sample database blocked for safety. Sample database is protected. Use a different database for testing deletions. So let's use the university database to perform the deletion. So what we will do is that we will add the three new users in the students table in the university database. And then we will perform the deletion. So let's do that. We will type add three new students in the students table in, let's say, SQLite University database. So it says that it will add three new students to the students table in the SQLite University database, and it has performed three new insertion operation for each new record, and then it will validate if the record we are inserting is validate or not by checking the new data with the schema of the table. So these are the new records that we have created, and it says total students now increased by 3. So let's check the students data, show the students data, and as we can see, these are the new students that we have added. Now perform a deletion operation. So let's say this record, and we will write a student record with this email address. So we have provided it with the email address. It has provided us with the preview of the record that is to be deleted. And it also knows that this is current student, one of the three we just added. And now it says that it has successfully deleted the student's record. So let's check if it is indeed deleted. Show the student's data, and the name of the student was Amanda Taylor. And also there is already an student named Amanda Taylor, but her email address is different. In our case, it was a.taylor, and in this case, it was Amanda.taylor. So this record has been deleted, as we can see. So we have successfully performed the deletion operation. Now let's see the data in the courses table. And it says that it will get the data from the SQLite University database. And here we have the data for courses. Now what we will do is that we will remove all the rows in which computer science is mentioned. So let's do that. We will write delete and then all the rows in which department is set to computer science. So it says that there are three computer science courses that would be deleted. So it knows that there are three records for computer science. And then it says in the summaries that total courses now 9 was 12. So three courses are deleted. Computer science department, no courses remaining. And then it provides all the other remaining information. Now let's check if they are indeed deleted. So let's say show the students data, and it is still showing the computer science. So we asked it to show the students data instead of courses data. So it has provided us with the students table with the computer science, which is marked by this warning sign, as these courses are not available now in the courses table. Now we will write show the courses data. And we can see here there are no computer science courses available. And it says code summary after computer science deletion. And all the information where it says missing departments, computer science and engineering is also not available, which was already not there. Now we will ask it to provide the complete schema for each table. So we will write get the complete schema for each table. So with the help of get table schema, it is getting the schema of each table for SQLite University database. So here is all the information related to the schema of the table for students table. And here we have column name, a type, and then we have null column, which tells us if a particular column supports the null value or not. And here we can see the ID supports the null value, but as it is a auto increment and primary key, it should not be null. And then we have a student ID, which does not accept the null value. The same for the name and email columns. They too do not accept the null values. And then we have age and major, year level, GPA, and enrollment date, and they all accept the null values. Then we have default column representing if a particular column has a default value if the value is not provided at the time of insertion. So we can see that all the columns do not have any default value, but we have here enrollment date, which has the current timestamp, which refers to the current date and time. And if the value is not provided at the time of insertion for this particular column, then it will assign the current date and time as the default value. Then we have primary key, and it tells us that if a particular column is a primary key or not. And here we can see the ID column in the students table refers to the primary key, and all the other columns are not, because there can be only one primary key in a table. Then we have a description column refers to the description of the column. For example, for ID column, the description is auto increment primary key because it will increment automatically when the data is inserted. Then here it is saying that it is a unique student identifier for the student ID. Then we have name column and it says student full name and so on. Now this is for the professors table. This is for the courses table. And here we have the enrollments table. So these are all these schema related information for all the tables. Now what we will do is that we will query all the tables and join them to create a comprehensive report with pagination. So let's do that. What we will do is that, and this time we will do it for the database that is in the PostgreSQL. So let's do that. We will write query all tables and join them to create a comprehensive report with pagination. We will write do it for PostgreSQL University database. So now we will perform the operation on the PostgreSQL University database. So it is getting the result for all the pages. It is calling query database tool multiple times. And here we have the report that is being generated. So it says that there are 33 enrollment relationships. Page size is 10 records per page. Total pages are 4. We have data sources mentioned here. So page 1 contains 10 records. So there are 10 records for each page. So we will write insert a new student and insert a new course and also create a new enrollment for them. So now it will insert a new student and a new course and it will create a new enrollment for them. So it is now calling the insert info database validated column to, to validate if the data that we are inserting is valid or not. And then it will do the same for the course as well as enrollment. Now the enrollment table has also been created. Now it will now it is checking each table individually. Here we can see the name of the student Maria and she is majoring in environmental science. And we can also see a course that has been inserted. We can see it is environmental chemistry and ecology. And we also have the enrollment that has been created, the Maria. And she is enrolled and the grade is not assigned yet. So we have successfully inserted a new data to the table. And that is how we can use this database MCP server to query and manage our databases directly through the chat. Instead of opening database tools or writing complex scripts, we can just ask questions and get our result back instantly. Whether we need to find customer records, update inventory, or check sales data, it handles all the technical stuff behind the scenes. We have seen how it can work with different database files at the same time, how we can add new records easily, and how it prevents us from accidentally deleting important data. If you need help with your projects, have difficulty learning these concepts, or want to deepen your understanding of how things like this work, Codersarts is here to support you. We offer personalized project assistance, one-to-one live sessions, help with building AI-related applications, and full development and deployment services. Visit us at www.codersarts.com or reach out directly at contact@codersarts.com. You will also find our LinkedIn, Instagram, and Facebook handles linked in the description box below. Thanks for watching and don't forget to like and share the video and subscribe to the channel so you never miss out our latest tutorials. Thank you.